In the previous slide, you were asked to determine how many committees of 3 people you could make with 4 people to choose from. So we had A, B, C, and D. And so what you should have found is 4 different possibilities. Now you'll see here I have a list of 24 different possibilities, but the only ones that are distinct committees would be A, B, and C, so where member D was left out, A, B, and D, where member C was left out, A, C, and D, where member B was left out, and B, C, and D, where member A was left out. If we read this chart here, looking vertically, you'll see that ABC, ACB, BAC, BC, ACAB, and CBA are all the same 3 people on the committee. And if the committee is just made up of general members, which is to say there are no roles or titles, so nothing to distinguish one member from another, then these 6 committees are really identical. And so here's where we start to distinguish combinations from permutations. If we consider these these 3-member committees from the 4 people, and order does not matter, then we're asking how many combinations there are, and there are only 4 of them. However, if there are titles, or if there is a race and we are ranking them, then this becomes a setting of permutations, and as you can see from the list, there would be 24 of them. For reference sake, we'll later note that from 4 elements we have chosen 3, and that has been equal to 4, or from 4 elements we have picked 3, and that has been 24. So we can show it as either a combination or a permutation, but we'll come back to that later. Now quickly we'll see how many times larger is the number of permutations compared to combinations. Well, if you divide 24 by 4, you can see that it's 6 times larger. Now where does this 6 come from? Well, we are arranging 3 elements, right? A, B, C, A, C, B, and so on. So here we are arranging 3 elements. There are 3 factorial ways to do that. That means for each committee of 3 people, there are 6 arrangements. So it shouldn't be a surprise that once we start considering order, the answer becomes 6 times larger. Does that make sense? So one way of saying that might be to say that for pick 3, or a permutation of 3 elements from a set of 4, is equivalent to 3 factorial times 4 choose 3. But we're actually going to think of it the other way around. We're going to think of it that a combination of 3 elements from a set of 4 is equivalent to the equivalent permutation, but divided by the ordering or number of ways to order 3 elements.